All right, so the end of investigation 1.3, we we started working on calculating the area of irregular shapes, right? Finding those areas. So over here, this is a square. What do you notice about this square? Hmm? Yeah, it's tilted, right? So for your kind of your first task for today, right now, because again, this is going to be a 2-day video, is I want you to take a look at this square with your team, and it says, is the figure to the left a square? So is this figure a square? And then how can you prove it? Take what you've learned from when we drew the squares, talking about finding how to find right angles, all right? Um, how to make sure that there are four right angles, all the sides are the same, all that information that we did, and come up with some reasoning here of why this thing is a square. All right. So you got the dots in here, just like we've had before when we were drawing the finding the irregular shapes, and see what you can come up with in terms of why this figure is a square, because it's not the traditional square you see with the horizontal and vertical lines drawn. All right. And come up with as many things you know about a square and what you've learned from perpendicular lines and all that good stuff. All right. And try to throw as many facts as you can down onto your sheet. And we're going to give you guys maybe about 7 minutes to do this. All right. So we're going to pause it and let you guys kind of get cracking here. All right. If you do get done with this before the 7 minutes is done, try to see if you can then use what you learned from 1.3 and calculate the area, which is the actual next question. All right. All right. So I saw people write, well, all sides have the same length. How do you know that? Besides measuring it. Let's say you could measure it. How do you know they're the same length? Well, we could find slopes of all these sides, right? If I go from this point here to this point here, right? I go up 1 and over 3, right? So the slope of this side here is 1/3, right? And then if I go to this opposite side, I go down 1, that's -1, right? And left 3, well, that's -3. So -1 over -3 is still 1/3. So if these sides are parallel, because they have the same slope. So if they're parallel and they have the same slope, that means they're the same length, right? Up 1 and over 3, up 1 and over 3. So these sides are the same length. All right? So we got to figure out that the other two sides are the same length. Well, if I go from this point here again to this point down here, so I go down 1, 2, 3, and over 1, right? So going down 3 is -3, and to the right one is negative, or is +1. So that's -3 over 1. And same thing over here. If I go up 3 and left 1, that's 3 over -1, which is still the same thing, right? So these guys are the same slope, which means that they're parallel, but they're also the same length. And because this line, this slope here, is the negative reciprocal of that slope, that means all 4 sides are the same length. So that's how I can tell you that all 4 sides are the same length. Okay. So again, not just writing it down, but it's proving why. Now, what do we also know about a square besides all 4 sides are the same length? Brad? It has 4 right angles, right? Well, how do we know these have 4 right angles? What did we learn in investigation 1.1 and 1.2? How do we know that 2 lines are perpendicular to each other? Because if they're perpendicular, they form a right angle, right? How do we know? Sam? Well, how do we know they have 90-degree angles? What's our proof? We spent investigation 1.1 and 1.2 learning about this, drawing our right triangles, drawing our squares, drawing our rectangles, Kelly. Well, if they're parallel, they're not perpendicular, which means they wouldn't form right angles. Come on, gotta think. Gotta put your thinking caps on. What are those two slopes? What are those two slopes right there? Yeah. 1/3 and -3/1 are negative reciprocal slopes of each other. So they're gonna when you have negative reciprocal slopes that touch, like for example, I'll use a different color. So if I go here, right, here's 1/3 and -3/1. So that angle right there is a right angle because of negative reciprocal slopes or opposite reciprocal slopes. Same thing with 1/3 here and -3/1 here. This forms a right angle because they have they're negative reciprocal slopes of each other. So that's how we form two of those right angles. But now if I go down here, if I use the same line here and this line here, well, this line is 1/3 and this line is -3/1. So there's your right angle here and 1/3 in here. So they form the right angles because all four sides have negative reciprocal slopes of each other. And when those two lines meet, with two lines that have negative reciprocal slopes of each other meet, they form a right angle. That's your proof, okay? That's your proof. So again, because 1/3 and -3/1 are right angles, they're going to form, or opposite reciprocal slopes, I mean, they form right angles of each other at all four sides. And that's how we can prove it instead of just saying it because we know that. All right. So let me take it. I want to take this out of the equation here because I want to go back to just looking at the figure now. All right, so we've proven it's a square, right? All four sides are equal, four right angles. So what's the area of that shape now? If I were to ask you what's the area of that square, because we know the area of a square is length times width, right? But we have no idea what this length is or what this length is, right? Now, give an interesting, Nolan measured them, right? What'd you come up with? You said 2 centimeters long, right? So technically by your estimation, it would be 4, right? And it's not. I'm gonna show you why. So remember how we did the irregular shapes? How could you find the area of this? All right, yeah, if we box in the irregular shape, right, we make a big square here, right? So it's a certain amount of units, right? So that blue square I just drawn, what would be the area of the blue square I just drew? How many dots by how many dots? So if I start here, this side is how long? 4 by, so it's a 4 by 4 square, right? A 4 by 4 square has an area of what? All right, so the blue square has an area of 16 square units, right? Well, now, inside the square, right, if I can find out the area of these 4 triangles, I can subtract it, couldn't I? Remember, isn't that what we did? So this right triangle here is a 1 by 1, 2, 3. All right, so if I look, this is a 1 by 3, 1 by 3. So all 4 triangles are the same thing, right? So these are 1 by 3 triangles. So if I find 1, I'll just multiply it by 4, right? And I can have the area of all 4 of them, right? Well, remember, area of triangle is half the base times the height, right? So if half the base is 1, what's half of 1? A half. And then when I multiply it by 3, 0.5 times 3. 1.5. So if one triangle is 1.5, multiply it by 4 of them. What's 1.5 times 4? 6. All right, so that means this blue area here that I'll just kind of quickly shade in, the combined area of all 4 of these blue little areas is 6. So to find the area of the square, what are we going to do? Yeah, take 16 minus 6, which is 10. So 10 square units is the area of that tilted square. So we did that. So it's kind of like the same philosophy we did with the irregular shapes, right? Except we don't have to deal with half triangles and those. I mean, a square is a much easier shape to deal with than some of those figures that we did in 1.3, right? All right. So we skipped the part where it says, oh, my copy is different. Okay, good. All right, so it says, what are the slopes of the sides of the square to the left? So I have a horizontal line and a vertical line, right? So we know that when a horizontal line meets a vertical line, it forms a what? Right angle, right? So we know that for sure. So what are all the slopes of the horizontal lines? Horizontal line has what kind of slope? 0, right? Horizontal lines have 0 slope. And what about vertical lines? What kind of slope does vertical lines have? These lines here. What's the slope of a vertical line, Brad? Undefined. So these 2 lines are the same slope, which makes them parallel. So we have 0 slope, lines with 0 slope and an undefined slope, they will form right angles. Okay? Because they're horizontal and a vertical line, and when they meet, they form a right angle every single time. So that's how we know that the slope is just enough to justify that the figure is a square. Because again, opposite sides, so this is the same length. Opposite sides are parallel here, same length. And again, all 4 right angles because the horizontal line meet the vertical line every time at a right angle. So yes, that would be enough information on something like this to know that's a square because it's set up nice and pretty like we're looking to see it, right? This is how we're used to seeing a square, right? Not taking it and tilting it. Okay? All right, let's go to the back page because this is where it gets interesting. And we won't finish this today. We will finish this tomorrow. So today we're only going to work with drawing the shapes and finding the area of them. So the first 2 columns. We are not going to do the far right column for the side length. That's going to be when we start investigation 2, which won't be till next week. So here's your task. I want you to take about 10 minutes. We'll see at 10-minute mark if you need any more time. But I want you to work on trying to draw the diagram of the first 3 types of squares. All right? So here you're going to the left make a square that has an area of 1. Then you're going to draw one that has an area of 2. Now notice that may be different, right? And then an area of 4. All right? And you got to remember, it's length times the width gives you the area, right? So some of these are going to be really easy to draw. Some of these are going to take a lot of thought to be able to put them on the paper. All right? So I know yesterday, remember during the practice, the retakes yesterday, we handed out those square roots. So think of things that are perfect squares and things that are not. And how is the shape going to look? So for about the next 10 minutes, I want you with your group to try to just solve the first 3. And then again, once you draw the figure here, okay, in the diagram column, you're going to come up with the area on the area column. All right, we're going to pause. Yes, they all have to be squares. So here, we'll start with the first one. So we just said it, right? So we know that area equals length times the width, right? And for a square, all four sides have to be the same. So you got to figure out, okay, length times width equals 1. So what times itself is 1? And everyone said 1 times 1 is 1. So I can draw a 1 by 1 square using these little. Now again, whether it's here, it's in the corner, but I just want to make sure this is 1 unit, right, by one, all the way around, right? So when I multiply it, the area is 1 here. Now I got to think to myself, what times itself gives me 2? A little tougher. And then what times itself gives me 4? So those are the other 2 you're going to come up with. All right? So now you kind of get an idea of how to do that. Go ahead and try to figure out 2 and 4. 2 will take a little bit of thought. 4, maybe not as much. All right. Let's come back to 2 in just a second. How'd you find the 1 for 4, right? How do you know length times width gives me an area of 4? So again, with it being a square, the sides have to be the same. So what number solves that? Right, 2 times 2 is 4, right? So one side has to be 2, the other side has to be 2. So you go 2 dots by 2 dots, right? Now whether you have it off to the side or whatever, but if you have a 2 by 2 square, right? That was the area of 4. Now look at, what do you notice about the first one and the second one in terms of the sides? What kind of numbers are they? What kind of numbers are 1 and 2? What kind of numbers are they? With the classification of numbers. 1, 2, 3, 4, 5. What kind of numbers are those? Whole numbers, right? And we have nice, easy, even numbers like this, whole numbers. They make a perfect square, right? Vertical line, horizontal line, right? Making our right angles, right? Was that triangle? Not triangle. Was the square over here that we did? Was that a perfect square? No, and we haven't figured it out. We won't do that till the next lesson, but we know that something by times itself won't evenly get us 10, right? Right? Hence why the square is tilted a little bit. Is that a perfect square? No, that's not a perfect square. But this one here and this one here are perfect squares, right? So here's a $1 million question. How did you come up with the second one? Because a few groups did, and I want you guys to share what you came up with. Kelly, you guys first. How did you come up with what you came up with? Tilted this square? What square did you tilt? You knew you had to draw a square that was kind of off center, right? Not like the first 1 or 3, right? All right, so you guys can see this. I'm going to use a thinner pen here. This is what their shape looks like. So she said she tried to come up with something in between. All right, Steven, what'd you do?
I just tilted it into a diamond and then I added up all the halves for the triangles.
How do you know what's a half? How do you know it's a half?
Because I know it's half the square.
In terms of half the square, I'm sorry, what do you mean? So you squared everything in here? Is that what you did? Like we did with the irregular shapes, did you box everything in here?
Yeah.
All right, so what he said he did is he took these little boxes, right? He made them into boxes like we did with the irregular shapes, right? And each of these squares are 1 by 1, right? But the triangle only takes up half of it. So he ended up basically with 0.5, 0.5, 0.5, and 0.5, right? Which all add up to 2, right? So that's how you figured out that one. Figuring out the area. Because it doesn't say up here the directions really. You have to use length times the width, right? Again, we're going to show you when we get to this part how to figure out the side lengths. Some are easy and some take a little bit of work. Because 1/2 times 1/2 isn't 2, right? Right? It's not. So, but that's how they did it, which was a good idea. What else? Anyone do something different? Probably could have also did it instead of little boxes in between. You could have boxed the whole shape in, right? So if I box the whole shape in, right, I have a 2x2 square, right? And a 2x2 square is 4, right? Right? Well, if I take the area of each of these little triangles that I'm coloring in here, it's a 1x1 triangle, right? What's half of 1? Half, and half times 1 is half, right? So each of these guys are a half, right? So what's 0.5 times 4? 2. Subtract 2 from 4 and I get boxing in the shape. Remember, we talked about that in 1.3, the irregular figures, right? All right, we're going to, now, so we're going to end the lesson today on this. I want you to take the information that you've learned with the squares that have an area of 1, 2, and 4, and see what you can come up with squares that have an area of 5. Because we know some number times itself, a whole number times itself does not go into 5 evenly, right? So the square is going to look more like this one than any of the first or the third one, right? So for the last 10 minutes or the hour, you guys are going to try to see if you can work on to come up with a shape that has an area of 5. It has to be a square, yes. But it may not look like this one or this one. All right, so we're going to pause again and let you guys give it a crack.